Welcome back, folks. Today we're going to be talking about solving quadratic equations. Now we're going to jump in by trying to figure out the steps for solving by factoring. Our first step is going to be make one side equal to 0. So first thing we're going to do is we're going to get the 6 over to the other side. We'll be left with x squared plus 5x plus 6 is equal to 0. Once we have one side equal to 0, what we're going to do is we are going to factor these sides. So for this, we make our ACB chart. We're looking for factors of 6 that add up to be 5. It's going to give us 2 and 3. Now because we can use this, the shortcut for this, we can say that this will be equal to x plus 2 and x plus 3 will be equal to 0. Next, we know that if two things are multiplied together to equal 0, one or the other must equal 0. So we're going to set each parentheses equal to 0. So we're going to get that x plus 2 equals 0 and x plus 3 equals 0. And our final step is just going to be to solve each of these. So we find that x will be equal to minus 2 and x will be equal to minus 3. Now this should be pretty familiar. We did cover this in Algebra 1, but we'll do some extra practice to make sure we get this. Starting off with problem 1. I'll go ahead and do this one. First step is to make it so that everything is equal to 0. So this becomes x squared plus 5x plus 4 is equal to 0. And we're trying to look for factors of 4 that add up to 5. That's going to be 4 and 1. And we can use the shortcut on this because a is 1 to say that we get x plus 4 and x plus 1 is equal to 0. From there we split this up. We say x plus 4 is equal to 0 and x plus 1 is equal to 0, which gives us our answers as x is equal to minus 4 and x is equal to minus 1. Why don't you all go ahead and try problem 2. Be careful, we can't do the shortcut because we have a 2x squared. What are we going to do? Well, we'll set up our ACB chart. We're looking for factors of 24 that add up to be 11. And that would be 8 and 3. So now we're going to set this up. We'll get 2x squared plus 8x plus 3x plus 12 is equal to 0. Factor this out. We'll get 2x, x plus 4, plus 3 times x plus 4 is equal to 0. Or that'll be 2x plus 3 times x plus 4 is equal to 0. We set each of these individually equal to 0. 2x plus 3 equals 0, and x plus 4 equals 0. We find that our answers are x is equal to minus 3 over 2, and x is equal to minus 4. Right. What about this next one? We have no b value in here, so b is equal to 0. That means we're looking for factors of minus 10 that are going to add up to 0. And try as we might, if we try 10 and negative 1, or negative 10 and negative 1, or 5 and negative 2, we're not going to find anything that gets us to 0. So the answer for this one is no solution. Okay, let's go ahead and try problem 4. Why don't you guys try it and tell me what the solutions will be. First step, we gotta get everything over to one side. So this becomes 7x plus 12 is equal to 0. And we're looking for factors of 12 that add up to be 7, which is going to be 3 and 4. So we know this is x plus 3 times x plus 4 is equal to 0, or this will be x is equal to minus 3, and x is equal to minus 4. Let's keep going. There's two ways you can do problem 5. You can bring the x squared over to the right side, or you can bring everything over to the left side. Either way, tell me what our solution is. For this one, I'm going to bring everything over to the left side. I don't like dealing with negatives. So this will become x squared plus 10x plus 25 is equal to 0. And factors of 25 that add up to 10, well, that's clearly just 5 and 5. As a matter of fact, this is one of those special cases we were talking about, where we see a number squared in our c place. So that tells us this will become x plus 5 times x plus 5 is equal to 0. Or we'll only have one solution here because it's repeated. Our solution is x is equal to minus 5. Let's do one more. Let's do problem 7. Now, how do we do this? Because we have no c. We're looking for factors of 0 that add up to 16? Well, not quite. We can just factor out of both of these. What do they have in common? They have an x. So we can say that this is x times 3x plus 16 will be equal to 0. From here, we're going to split this up so that it's either x, this first term, is equal to 0, or 3x plus 16 is equal to 0. From here, we see that x will be equal to 0, or x will be equal to minus 16 over 3. So that's our basic refresher on factoring, solving by factoring. What about solving by graphing? Well, there's two different ways that we can solve by graphing. The first is we can look at something like this. 2 absolute value of x plus 1 minus 3 is equal to minus 1. What were we doing before? We were setting one side equal to 0. So let's do that here. We get 2 absolute value of x plus 1 minus 2, because we'll add the 1 over, is equal to 0. And from here we can graph this absolute value equation. It looks like our vertex is at minus 1, minus 2. So we'll go to the point minus 1, minus 2. We'll plot our point minus 1, minus 2. And we'll go not up 1 over 1, like we expect from an absolute value, where we go up 1 over 1. We're going to double these each because a is 2. So we'll go up over 1, up 2, over 1, up 2, over 1, up 2, and so on. Now the question we have to ask ourselves is this is supposed to be equal to 0. So where's this graph equal to 0? Well, it looks like right at those 2 points. So our solution will be where the line crosses 0, or the x-axis. For this, it looks like that's going to be x is equal to 0 and x is equal to minus 2. So that's one way we can solve by graphing, is we set one side equal to 0, we graph, and then we figure out where it crosses the x-axis. That's not going to work so well for this second one, because we don't know how to graph x squared and the absolute value of x at the same time. So what we're going to do is we're going to graph both of them. Let's graph x squared first. That's our typical parabola, where we start at 0. 1 squared is 1. Negative 1 squared is positive 1. Right? This is based off of our table, x and y. Where we go 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So then we'll go out to 2. We'll go up to 4. 1, 2, 3, 4. We'll go out to negative 2, and negative 2 squared is also 4. Then we'll go up to 3, and we'll go all the way out to 9. And we'll go all the way out to 9. So this is our graph of the left-hand side. Now we need to graph the right-hand side. The right-hand side is negative absolute value of x plus 2. So that means we're shifted up 2. And instead of going over 1, up 1, we're going to go over 1, down 1. So So we're going to go over 1, down 1, over 1, down 1, and so on. And we'll do that the same going the other way. And we'll graph these. Now for this one, we said x squared is equal to this other function, meaning just like when we were solving by graphing, we want our solution to be where these intersect. And it looks like we have an intersection there. It looks like we have an intersection there. Meaning that our solutions we expect to see are x is equal to, what is x in this? It's minus 1 for the left side, and x is positive 1 for the right side. Let's double check these, make sure they're correct. Is negative 1 squared equal to negative absolute value of negative 1 plus 2? So this is 1, negative 1 squared is 1, is equal to, absolute value will cancel out that negative, but we're left with the negative. So minus 1 plus 2. That's true. What about for x is equal to 1? Is 1 squared equal to negative absolute value of 1 plus 2? It is, because that's 1 is equal to minus 1 plus 2. So these are the two ways you can solve any system by graphing. However, we're going to focus on this left one for solving quadratics by graphing. Our first step is going to be get one side equal to 0. So for this one, we're going to do that by subtracting 10. We'll get x squared plus 3x plus 10. Step 2 is going to be graph the equation. Step 3 is going to be find where it crosses the x-axis. Find the graph passes the x-axis. And then step 4 is going to be to check our answer. So let's go ahead and graph x squared plus 3x plus 10 is equal to 0 in our graphing calculators. See where that gets us. Back with that ready to graph. So let's go ahead and hit the graph button. Oh, and it looks like my window was set wrong. How do we fix that? Well, we go to zoom, and we want to move it back out to a standard zoom. So a zoom 6 will get us to where we want. And we see our graph here. We're looking, we think these 2 points it looks like is going to be minus 5 and 2. Now how do we make sure of this? Well, our calculator has a handy tool for this. See, zeros are a very common thing in math. So if we press second and trace, or we go into the calculate menu, we'll see that the second option here is to calculate a 0. So we'll click on that. It'll ask us for a left bound. So we're going to want to choose a point to the left of where we think our answer is. In this case, we're going to go just a little bit left of this one. We're going to hit enter. Second question it's going to ask us is, where's the right bound? What's a point to the right of where we think it is? So we'll go over a little bit to the right of where we think this 0 will be, and we'll press enter. And then it'll ask us for a guess. This is just asking, where should we start looking? And I guess starting looking at minus 5, 0 makes sense. It tells us that our 0 is at minus 5. So that's good. Let's go ahead and try that again with the other side. So again, we're going to press second, trace. We're going to hit that calculate. We're going to look for a 0. It's going to ask us for a left bound. Let's get this close to the other one where we expect it. So we'll bring this close to where we think that 2 is. Then it'll ask us for a right bound. We're going to move all the way over to the right of where we expect that to be. And for a guess, we can just click enter again. It tells us our second 0 is 2. So what are our solutions? Our solutions are x is equal to 2 and x is equal to minus 5. Now I know this is a little confusing, so let's go ahead and have you try a couple by graphing. For this first one, what we're going to do is we're going to set x squared plus 1x minus 12, so we're going to subtract the 12, equal to 0. Next thing we're going to do is put this into our calculator. So we get to our calculator, let's put it in. Y is equal to x squared plus x minus 12, and graph it. It looks like our zeros are at minus 4 and positive 3. Well, let's double check that. We're going to hit that second calc. We're going to hit 2 to find the zeros, and we're going to put in a left bound to the left of our answer, a right bound to the right of our answer, and we're going to hit our guess. That tells us one of our zeros is minus 4. Let's check the other one. Again, we're looking for a left bound, so let's get close to 3 here. That seems pretty close. Check our right bound by moving it to the right point, and we'll hit enter. We see that our second zero is 3. So our two answers here are x is equal to 3 and x is equal to minus 4. What about this second one? What will our answers be for that? Well, for this one, we're going to move the 1 over to the other side. So this becomes 2x squared plus 4x plus 1 is equal to 0. Let's go ahead and graph that. So here we are. We're going to put it in. 2x squared plus 4x plus 1. We're going to graph that, see where it equals 0. Now this one looks a little bit more confusing. It looks like our answers aren't quite as precise. This is where that 0 tool will be super useful. So let's hit second calc. Let's find our zeros. We're going to start with a point to the left. We're going to get a point to the right. And we're going to try to calculate that. It tells us our 0 is minus 1.707107. So let's go ahead and round that to 3 digits. So minus 1.707 to the thousandth place. So one answer is x is equal to minus 1.707. The other is x is equal to minus 0.293. So those are our two answers. We have x is equal to minus 1.707, and we have x is equal to minus 0.293. Those are our solutions. All right, let's tie it up with a little bit of an application problem as well. This time we have a ball passing through the air on a parabolic path, so this is a quadratic, and the function is f of x is equal to minus 8x squared plus 20x plus 4. So, what was the initial height of the ball? We talked about this. The initial height was the y-intercept. What was the y-intercept? The y-intercept is our constant here. So the initial height of the ball is 4 feet. When does the ball hit the ground? Now we can solve this in any way we want to, or any way that works. So we can factor this, or we can graph this. I think let's go ahead and graph this. So here we are. We have this ready to graph. Let's hit that graph button. Okay, and it looks like it hits the ground pretty quickly. Let's figure out what our two zeros are. We're going to hit that calc, go down to 0, and we have an answer just negative. So let's see what that is. The answer is minus 0.186 seconds. Now, is that going to be our answer? No. Why is this? Well, we're not looking for a negative time. That doesn't make sense with what we're saying. We're looking for when the ball hits the ground, and we know it starts at 4 feet. So we're going to check the other answer instead. Going to calculate that, pick a point to the left once this gets back onto our screen. There we go. We'll pick a point to the right, and we'll take an estimate. The estimate looks to be 2.686 seconds. So that's our answer for when the ball hits the ground. So by graphing, we found out that it was 2.86686 seconds. What about what is the highest point, and when will it be at that highest point? This is asking us for our vertex. Now let me show you something cool here. What we're doing is we can put this into our calculators and figure out the highest point and when it will be at the highest point. Let's go ahead and go back to our calculators and check that out. We're back at our calculator. Let's fix our window so that we can see what we want to. Now we don't really care about the negative numbers. We'll make this -1 just for safety. Our x max, 10 was far too large, so let's go to 5. Our x minimum, we don't really need anything under 0. And our x max, it went off the page, so let's try going to 20. And let's graph this again. Here we see a much better view of our parabola with the peak here. Now we could try to test the vertex by doing b/2, negative b/2a, or our calculator has a trick that'll allow us to do it as well. If we press second, calculate again, you'll notice just under 0, number 4 is our maximum. So let's go ahead and click that, see if we can figure this out. It's again asking us for a left bound. So we're going to want to go to the left of where we think the maximum is. Something over on this side where it's very clear not maxed out yet. And it's going to ask us for a right bound. We're going to choose another point way over on the right here and give our guess somewhere in the middle. And this gives us our answer. And it tells us what our maximum is. It tells us the time, which was x, and the height, which was y. So our maximum height is 16.5 feet, and the time is 1.25 seconds. So let's mark that down. Our highest point was 16.5 feet at 1.25 seconds. And finally, it's asking us when will the ball be at a height of 6 feet. So this time, what we're going to say is our height is 6 feet. So we'll say 6 is equal to minus 8x squared plus 20x plus 20x plus 4. So for here, we're just going to do what we always need to, which is set one side equal to 0. So this will be 0 is equal to minus 8x squared plus 20x minus 2. It's asking us when the ball will be at a height of 6 feet. So here we have it. Now we could either do this graphically or we could do it by factoring. Let's go ahead and do it graphically. We're going to put this equation into our calculator now. So here we are. We changed our 4 into a -2. Let's try to graph this. And we see we have an intersection over here. Let's change our window down because we want to be able to get the left side of that. X min is -1, X max was okay. We'll make our Y min -5. And so now we can see where this will hit 6 feet. Are we going to calculate it? Well, we'll go to calc. We'll look for our 0. We want our left bound to be on the left side of this 0. We want our right bound to be on the right side. And we'll hit enter to calculate it. That tells us what our 0 is. It tells us our 0 is 0.104. So we'll reach a height of 6 feet at 0.104 seconds. And finally, one last type of problem. Now we're trying to write a quadratic equation that has a solution of 5 and -7. You might say, wow, this is really tough. But here's what we're going to do. We're going to say we know x will be equal to 5, and we know x will be equal to -7. And from here, we're going to reverse engineer what we did. So we're going to reverse our steps. So we want to get both of these sides equal to 0. That tells us we'd have x minus 5 is equal to 0, and x plus 7 is equal to 0. So all we're doing is we're anti-factoring here. We're going through the reverse steps. Right? Typically, we'd go from the second step to the first, but now we're doing it in reverse. And how did we get these two split up? Well, they needed to be multiplied together. So this would be x minus 5 times x plus 7 is equal to 0. And our last step would be to FOIL these. So our answer would be x squared plus 7x minus 5x minus 35 is equal to 0, or x squared plus 2x minus 35 is equal to 0. Not 6, to 0. We have one more of those to try, so why don't you all try that? Write an equation that has a solution of minus 2 and 9. So for this one, we want a solution of minus 2 and 9. We'll start by saying x will be equal to minus 2, and x will be equal to 9. Now we're going to get the right side equal to 0, so we're going to add 2. We get x plus 2 is equal to 0. We get x minus 9 is equal to 0. Then we're going to combine these two into two equations. So x plus 2 times x minus 9 is equal to 0. Right? We know that this will have a solution of minus 2 because we got a solution of minus 2. We know it'll be 9 because we have a solution of 9 here. Now we're going to FOIL those out. We'll get x squared minus 9x plus 2x minus 18 is equal to 0. Or our answer is x squared minus 7x minus 18 is equal to 0. And there you have it, folks. A little bit of a review on how we solve for quadratic equations.